Hello everyone. So we are going to start the size reduction. So basically you see the size reduction, it is the most important process in the formulation and development of any dosage form. As we know that the drug they remain in different sizes or sometimes they may be available as a bulk drug with a bigger size. So to incorporate the drug in definite formulation, for example tablet, capsule, or sometimes making the solution or emulsion, we need to reduce the size of the drug. So in this presentation I have divided the whole portion of size reduction into three parts. So here we are going to study the different aspect of size reduction, their application, their objective, how we perform the size reduction. So without wasting any time, let's start the part 1 of size reduction. So you see, what is the definition of size reduction? So basically, if somebody asks you, the size reduction is simply a operation which is carried for reducing the size of a bigger particle, any bigger particle, suppose a big piece of stone into sand or into crushes of stone dust, right? So it is the operation which is carried out to reduce the size of a bigger particle into smaller one to have or to achieve a desired size and shape, but with the help of external force. And this term size reduction, it is also known as comminution. Comminution means the size reduction, right? So here you can see these are the bigger size particle. Upon applying the external force, they are crushed down or they are finally getting decreased into smaller size particle, right? So the size, it refers to the physical dimension of any object, right? Moreover, reduction, it refers to the decrement, or the process of decreasing of the size. Now you see the objectives of size reduction, why we perform the size reduction, right? So first of all, you see the first objective of size reduction is nothing but it increases the surface area. Upon decreasing the size of a particle, the first and foremost thing is that the surface area of the particle will increase. So it increases the particle surface area. In most of the reaction, for example, which involves solid particles, the rate of the reaction, it is directly proportional to the area of contact with the second phase. So for example, I am telling you the catalyst which we use in different sort of organic reaction, the catalysts are generally used in a powdered form. I hope you people remember while studying the organic chemistry, we use iron dust, zinc dust, aluminum dust. Why dust? Why we use the dust? The dust means the iron, it is broken, or the aluminum or the zinc, it is broken. It is a smaller particle to initiate the reaction or to fasten up the reaction, because upon decreasing the size of the particle, the surface area increases where both the reactant can easily come and react with each other, right? The next thing is that break a particle into a smaller part in order to separate the valuable amongst the two constituents. So if you are having a compound which is having two important constituents, then breaking the compound will lead to the decrease of the size. Moreover, you can separate the two valuable components from a single component. Clear? The next one is to achieve intimate mixing, because if we take the example, suppose we have 100 numbers of stone, smaller stones, sandstone we have, and we have 100 numbers of marble. Now if somebody asks you to mix it properly or intermediately without breaking, you cannot mix it properly, because after mixing also the stone will remain as a stone, the marble will remain as a marble only, right? But if we break the stone, or if we decrease the size of the stone into stone dust and even the marble into marble dust, and upon mixing, the mixing will become quite close, it will become intimate, right? Moreover, to to dispose the solid waste easily. Most of the time, the solid waste, they are broken down into smaller pieces so that they can be easily disposed, right? To improve the handling characteristic, to improve the handling of any substance, it is always preferred to decrease the size of the substance. Moreover, to mix the solid particle more intimately, which I have already explained. Now you see advantages of size reduction. So first of all, content uniformity. When we are going to decrease the size of the particle, if somebody asks you what is the content, you can easily explain the content, because the smaller particle will have bigger surface area which will directly depict the content. And regarding the content uniformity, means the content of the whole area which having the powdered form of any drug will have equal amount, because they are having smaller size. The next is uniform flow, because during the time of tablet preparation, what we used to do, we used to powder the drug, then we used to make the granules. So proper powdering of the drug or proper surface decreasing of the drug may or will lead to the proper formation of the granules, and these granules will help in the uniform flow to the from the hopper to the feeder to form or to make the tablets. Next, if we are going to decrease the size of the particle, it will help in the effective drying, because the dried particles or the smaller particles will have more surface area. So once the surface area is more, the drying will be quite fast then. Next is increase of the surface area or viscosity, that we already discussed. Next is the uniform mixing and drying. It helps in the uniform mixing and drying. Then it helps in the rate of absorption, because it has been found that the smaller particles are easily absorbed as compared to the bigger particle in the body. Moreover, it improves the dissolution rate. So what is dissolution rate? Dissolution rate is nothing but when we put a tablet in a glass of water, initially the tablet it start disintegrating, it get break down into different forms of granules. After some time it get diluted, means it will get completely miscible with the liquid, right? So if we decrease the size of the particle, then definitely the rate of the dissolution will increase. But there are some disadvantages also. So what are the disadvantages of size reduction? First of all, you see sometimes the drug may get degraded. Moreover, contamination may take place. Contamination may take place due to the size reduction. So now application of size reduction, where it is applied. First of all, you see the size reduction is actually help in the rapid solution formation in case of chemical substance. How? For example, if we take sugar crystal, if we mix this sugar crystal, suppose 1 teaspoon of sugar crystal we have taken, we have mixed with 1 glass of water, it will take suppose 1 minute. But similarly, if we take powder or crushed form of sugar, and if we mix it in the water, it will, or it may take hardly 30 seconds. Thus you can say the reaction, it fastens in case of chemical substance, right? Moreover, extraction from the animal gland. Suppose we are extracting something from the animal gland like liver and pancreas, or sometimes crude vegetable drug, it is facilitated. The extraction process from the glands of animals, like suppose we are extracting something from the liver or pancreas of animal, or we are extracting something from the crude vegetable drug. If we decrease the size of the gland, or if we decrease the size of the crude vegetable, then the solvent can easily penetrate in the powdered form of the gland or in the powdered form of the vegetable drug, and thus it fastens the process of extraction. Clear? The next one is that the therapeutic effectiveness of some drug, it is increased by reducing the particle size, because upon reducing the particle size, the surface area of the drug will increase. Thus, the therapeutic effectiveness of some drug it increases. For example, the dose of griseofulvin. Griseofulvin, it is a drug which is used against fungal infection. This is an antifungal drug. So the dose of the griseofulvin is reduced to half if we decrease the size of the griseofulvin. The next one is that mixing of powder. Since different size particles do not mix uniformly, thus when we mix the powder, if we decrease the size of the powder, right, then the mixing it occurs fastly or uniformly. The next one is that the size reduction is important in case of suspension also. So we have seen different suspension. Suppose for example we have even consumed the antacid suspension like your Gelocil and all, right? There we have the particles which are there. These are the drug particles. Before using that, we need to redisperse the suspended particle by gentle shaking, right? But if the size of the particle that was in there in the formulation of antacid, if that was too small, then sometimes caking may happen. Caking means they will settle permanently at the bottom. You cannot redisperse it. Thus, size reduction is a very crucial term in terms of making or formulating a suspension. The next one is that the size reduction, it is also important in terms of tablet production. As I have already told you, the crude drug which we are taking, the API, we are going to make this API in powdered form, right? Afterwards, we are going to use the additives. So this API stands for the active pharmaceutical ingredients, and additives here we can use lactose, sucrose, starch, anything. Now proper mixing and proper size reduction of the additives as well as the drug particle, they help in the process of tablet production. The next one is that in case of inhalers, we use different inhalers for upper respiratory tract infection, right? Now you see, in the inhalers, when we inhale the inhaler, it leaves some particles which moves into our upper respiratory tract. Now if the size of the particle is very small, then what may happen? If the size of the particle is very small, then this particle may come out with the air you exhale from your bronchioles, right? Moreover, if the size of the drug is, or the particle is bigger, then it may not get absorbed in the bloodstream. So for formulation of the inhalers also, the size reduction method, it has a crucial impact. The next one is that the size reduction actually it improves the appearance of ointments, paste and creams. These all are topical formulation. Their physical appearance it is improved with the size reduction. Moreover, all the ophthalmic preparation which are generally applied in the eyes, right, or the topical preparation, they should be free from gritty particles to avoid irritation. Thus, the size reduction is very important in the preparation of ophthalmic preparation as well as topical preparation. The next one is that the decrease of the size particle, or you can say the decrease in the size or the size reduction, it increases the stability of some preparation. For example, in case of emulsion, if we can decrease the size of the oil globule, then the emulsion it remains stable. So emulsion, it is nothing but emulsion is a mixture of oil and water phase, or you can say two immiscible phases are mixed together, right? Moreover, the decrease of the size particle, it increases the rate of absorption of the drug from the body. Moreover, the rate of drying, it increases upon size reduction because the surface area of the particle it increases, thus the process of drying it become fast. Moreover, to reduce the bulk material, since shipping charges may be based on the volume. Suppose we have 1 kilo of a drug, right? Now this 1 kilo of the drug, it is having a bigger volume. Suppose if we reduce the size of the drug by crushing it, then the volume of the drug may get decreased, which also sometimes helps in the process of decreasing the shipping costs. Now you see limitation of size reduction operation. What are the different limitations? First of all, you see this size reduction process, these are not suitable for drugs which contains volatile oil, for example cinnamon and clove, because if we reduce the size of the cinnamon or clove, what will happen? The volatile oil may get lost. Moreover, due to the increase of the surface area upon the size reduction, I repeat, due to the increase of the surface area upon the size reduction, process like oxidation and hydrolysis may occur on this drug when they are exposed to the atmospheric condition. So in such cases, the drug need to be in a it need to be stored in a well closed container at a cool place. So now how we can achieve the size reduction? Basically there are two methods. Number one, it is the precipitation method. Number two, it is the mechanical process. So in the precipitation method, what we are going to do? Here we are going to do simply the substance or the drug, it will be dissolved in the appropriate solvent, right? In the mechanical process, what we are going to do? We are going to crush the substance by using equipments like ball mill, colloid mill, etc. So see what actually happens in the precipitation method. First, the drug or the substance, it is mixed with a solvent, right? A mixture you will get or a solution you are going to get. Then you use another solvent. By virtue of this another solvent, this mixture will again get precipitated. Suppose we have a solid piece of drug, it is mixed with water, and then we have used one organic solvent which is immiscible with the water. Then what will happen? We will get precipitated formation. This precipitated formation is again going to get reduced in size, and thus you can get the smaller size particle. It is used for drug like calcium carbonate, yellow mercury oxide, bulk drug, etc. Whereas in the mechanical process, what we are going to do? The substance it is used, mechanical force will be applied, like grinding equipments like ball mill, colloid mill, etc. The size will be reduced, and then finally you are going to get the lower size particle, right? So basically we have two grinding method. One, it is the dry grinding method, which is applied in the formulation of tablets and capsule, whereas we also have the wet grinding method, which is used in the suspension, emulsion and ointments. Now you see mechanism of size reduction. What are the different mechanisms which are applied in the process of size reduction? First of all, impact. Impact is nothing but, suppose a particle is reduced by single rigid force. You have taken one hammer, you have crushed a piece of stone or a drug. This is impact, right? Next we have compression. Here what will happen? The drug particle, it will be crushed. It will be crushed between the rollers. It will be crushed between the rollers by application of pressure. When the two rollers, they are moving in the opposite direction in a close contact, if you put something in between this roller, the drug particle will get crushed, right? The next one, it is the attrition. Attrition is nothing but it arises from the particles scraping against one another, or you can simply say against the rigid surface by rubbing. This is attrition. The next one, it is cutting. Cutting means the material is cut by means of sharp blade. So here you can see this is the impact. So this is the, suppose the hammer, this is the particle, you are going to apply the force here, it will get crushed. This is the attrition, right? So here you are applying the force in this direction, this particle, this is stationary, it is applying the force in this direction. The particle in between, they get sheared or they get broken into smaller pieces. This is the shear. You can see the force it is applied here. This is a stationary particle, the stationary object. This is the particle. When you are applying here, it will get crushed. This is the compression. You are applying force from this direction, you are applying force from this direction. In between there are particles which are getting crushed. Moreover, you can also apply smashing. This compression can be also termed as a smashing. Force it is applied in this direction, it is smashed. This is the breaking. Again, this is the attrition, right? This is the splitting in the two equal halves. This is the cutting, and this is the crunching. So these are different mechanism via which the size reduction can be achieved, right? Now you see the classification of size reduction equipments. So basically we have classified them into 4 types. Number 1, crusher. Number 2, grinder. Number 3, ultra fine grinder. Number 4, cutting machine. In the crusher we have example edge runner mill and runner mill. In the grinder we have example hammer mill, rolling compression, roller mill, attrition mill, etc. In the ultra fine we have fluid energy mill. In the cutting machine we have cutter mill. Now you see in this chart this crusher, how this crusher example, these are edge runner mill or end runner mill. Grinders, their example are impact mill, example is your hammer mill, rolling compression, roller mill, attrition mill or attrition mill, here attrition mill is there, tumbling mill, example is ball mill, ultra fine grinder, fluid energy mill. These are the examples of the different mills. We are going in details in the coming slides. Now you see in the hammer mill, what mechanism we are going to use? Simply impact. And this hammer mill, it is used for almost all type of drugs. Roller mill, here we are going to use both attrition as well as compression. It is preferable for soft material. Colloid mill, it will use the mechanism impact and attrition. It is mostly used for the drugs or brittle drugs. Ball mill, same only the brittle drugs. Fluid energy mill, it is generally used for moderately hard and friable materials. So these are the different types of mechanism which are used by this mill, right? Now type of impact, or you can say when impact forces are applied. First of all, gravity impact. What is gravity impact? Simply, in gravity impact, a free falling material is momentarily stopped by a stationary object. Suppose we have picked up a drug particle or a stone, we have released it from certain height. When it will go and hit the floor, it will be stopped by a stationary object. It is the floor, right? This is the gravity impact. Now you see, for example, the coal, it is dropped on onto a hard steel surface. The next one, it is the dynamic impact. What actually here is that most often used it is. So most often used, it is necessary to separate two material which have relatively different friability. Means one it is quite hard, another one it is quite soft. These are having two different friabilities. In such cases we are going to use the dynamic impact. The more friable material will get broken down fast, whereas the tougher one, it will get broken later on. Thus the less friable will remain unbroken. So example, the material dropping in front of a moving hammer. If you are dropping something in front of a moving hammer, if the substance it is softer as compared to the hammer, the substance will get fast break, whereas the hammer will remain as it is, right? Now when compression forces are needed, if the material is hard, then only you are going to apply the compression force. If the material is abrasive means it will have different physical texture which can abrade or which can tear out the surface of the material. If the material is not thick, then you can use compression force. Moreover, when the material will break cubically, also then you can use the compression force. Where the finished product is relatively coarse in size, then also you can use the compression force. Clear? Now you see, what are the different factors which affect the size reduction? There are many factors which will affect the size reduction. First of all, hardness. Hardness is the surface property of a material. We know that, right? So, thus it is possible for a material to be hard, but if it is brittle also, the size reduction may present no special problem. Hardness, it don't have such problem, but the thing is that if the material is hard as well as it is brittle, you can easily achieve the process of size reduction. We have a scale. This scale, it is known as Mohs scale. This Mohs scale is an arbitrary scale which is used to measure the hardness of any material. The scale, it ranges from 1 to 10. In this scale, up to 3 we consider every material as soft, but above 7 we consider every material as hard. Right? So generally the harder the material, the more difficult it is, means it is for reduction of size, because we need to apply more amount of energy, right? Next one, it is the toughness. The toughness, it is very important as compared to that of the hardness, because you see, since a soft but a tough material is harder to reduce in size compared to a hard and brittle material. Maybe your substance may be soft, maybe the substance may be soft, but it may be tough. In such cases, it is very hard to reduce the size. But if the substance is hard, but if the substance is brittle in nature, you can easily break it. But if the material is soft also, but if the material is tough, it is very hard to break it. So the toughness of the material can be reduced by treating the material with liquefied gas. If we decrease the temperature to up to suppose minus 100 degrees centigrade or 150 degrees centigrade, the rubber, which is a sticky material, which is a very tough material, right, it also becomes brittle and it breaks. Clear? Now, this method, it is not always applied. The cooling method, it is not always applied because the low temperature may spoil the nature of the drug, number one. Moreover, it can also affect the machine material. Thus, the machine can also become brittle and it can also get break also, right? The next factor, it is the abrasiveness. Now, a property of hard material, particularly which are originated from the mineral, they have a limit in the type of machinery that is used for their grinding, because if the material is abrasive, suppose we are using sand or sand dust or some abrasive material, then if we are using this sand dust or any abrasive mineral in a crushing material, the abrasive nature of the mineral may lead to the torn out or worn out of the material of the machine. Thus, after the grinding process, you may get the powder of the drug or the mineral as well as some powder from the machinery also. Maybe that may be steel or iron, whatever it is, right? Then the next nature, it is the stickiness. So gummy materials may adhere to the grinding surface, especially if the method used for size reduction it generate heat. So stickiness, it is another factor which affect the size reduction. So in case of size reduction of the gummy material, we need to be cautious. In such cases, complete dryness of the gummy material may help in the process of size reduction. The opposite is that slippery material may also pose problem to the size reduction, because if the material is slippery, then suppose we are applying the force between two rollers, the rollers, they will also get slip, right? The next is the softening temperature. So waxy substance can soften due to the heat generated from the grinding process. So softening temperature is also an important criteria in size reduction, because in the process of size reduction, huge amount of the heat it is generated. The next one, it is the material structure. So minerals, they generally have lines of weakness. A mineral particle generally have lines of weakness. If you apply the pressure on the lines of weakness, it will immediately get ruptured or it will get breakdown. Similarly, the cellular structure of the vegetable drugs, they also affect the size reduction of the vegetable drug. The next one, it is the moisture content. So what is moisture content? It is the amount of the water that is held by the substance. So The moisture content, it affects the properties like hardness of the drug, toughness or its stickiness. So in general materials which are subjected for the crushing or size reduction, they should be dry or wet, but not merely damp. Clear? So less than 5% moisture, it is suitable for grinding means dry grinding method. But more than 50% moisture, if the drug is having more than 50% of the moisture, then it is suitable for wet grinding. The ratio of feed size means anything we are putting for size reduction. This is the feed to the machine. The ratio of feed size to the product size. If the size of the original drug is too large, it may be reduced to the small particle in stages, not in a single stage, but it has to be reduced in stages, different stages. The next one, it is the cost. See, all this process, they are associated with the formulation of the drug, so we need to consider the cost also. The cost, the labor expenditure, the time involved in the process of size reduction. The next term, it is the purity required. So may need to carry out grinding in aseptic condition when in case it is essential to keep the material free from bacterial contamination. In such cases, the drug or the material, it need to be grinded in a aseptic condition. The last one, it is the environment. So if the drug, it is very potent, then the closed mill need to be used so that the drug particles, they don't spread to the worker who are working in the process of size reduction. Clear? Now you see energy requirement for the size reduction. So basically here we have found it as little as about 2% of the total energy consumption is used only for the size reduction. Means whatever energy we have applied for size reduction, only 2% of the energy has been used in the size reduction, whereas the remaining 98%, it is lost in many other ways. Where it is lost? Number one, the energy may be used for elastic deformation of the particle, right? Number two, the energy may be used for plastic deformation of the particle without the fracture. See, you see here I have shown you the elastic deformities, this is the plastic deformities, right? Moreover, deformation to initiate the crack that causes the fracture, right? Deformation of the metal machine part, sometimes the energy which is used by the machine, that can also causes the deformation of the machine part, right? Moreover, interparticulate friction, here also most of the energy, they get lost during the time of size reduction. Moreover, the drug particle or substance particle as well as the machine wall friction, some of the energy is lost, and mostly the energy, it gets lost in the form of heat, sound or vibration. Thus the overall energy which we are applying in the process of size reduction, only 2% of the energy is utilized, remaining all the different, these are the phenomenon where the energy, it is wasted. So thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video with your classmates, and for further notification from this channel, you can subscribe my channel. Thank you once again.